In this case, would this graph be discrete or continuous? I'm going to say it's continuous because it's continually getting filled up with water, right? As time ticks on, something's always happening. Okay. So about 3 seconds in, it's at 100. Looks like another 3 seconds goes by, it's about at 200. Another about 3 seconds goes by, hit another 100. But again, we just answered, we're not just plotting points here because even at 12 seconds, it's at like 450. So there's still something going on. That's why it's not discrete. There's still something going on at this time. It's continuous. Okay. And going on all the way up to when we get to 15 seconds, we've topped out at 1,000. So what's going to happen is I would like you to try and do the graph of what you think that would look like. And then we're going to watch what they get as an answer on the graph. If yours is way different than that, just draw over the top of it. You don't need to worry about erasing it. I'm not grading these on if they're right or wrong. Just that if you can attempt it and see if you can get close to graphing the situation. Does that make sense? Here's what they have as the answer. It's continuous because it's continually being filled with water, right? Time is still ticking on. The time doesn't stop. If the time stopped, then it might be discrete. But that's what they have as a graph. Do we get something close to that? Pretty straightforward because only one thing happened. Time ticked on. It continually filled up with water at about the same rate. It increased at about the same rate. So ours should look something like that. If yours is a little off, just draw over the top of it what that would look like. Okay. Here's what they had as an answer for this graph. Again, independent variable is time, dependent is height of his waist. They also started at 3. He was increasing at a constant rate. They took him up to about almost 10. There's his plop down. Now this is the part sometimes some people miss, is what's happening at this time right here. In the picture. He was just sitting. Time was still ticking on, right? Time's independent of anything else. Time was still ticking on, but his waist wasn't changing from the ground. So time was still moving on. Okay? And then he's going down the slide. Notice they have him going a little bit closer than where he started because what did he do at the end? Anybody recognize that? He kind of bent his legs at the end. He squatted a little bit and then stood up, right? And then when he stood back up, he's back to where he was at the beginning. You get something close to that? No. Not bad. A little off. That's usually the part. This is where he plopped down, right? That's usually the part that catches some people. And then the dipping underneath, that was kind of hard to see in the video, but that's what it was. Okay? So that's what they have as the answer for that one. Let's go to number 3. Here's what they have as the answer. Again, we're starting at 3 feet. And very quickly it drops. It hits 0. And within 4 seconds, it's staying on the ground, right? And it's kind of hard to tell, but it's just staying on the ground. Time's still going on, but the height hasn't changed. So this one happened very quickly. Hit the ground. It bounced back up. Not quite to 3 feet again, right? Maybe about halfway. It hit the ground again very quickly. Again, this all happened within just a couple seconds. It bounced up, hit the ground again, a short little bounce, and then it just stayed on the ground. Get something like that? No. Close? Now, that one's tough because it all happened so quick, right? The whole part of the graph is right here because then it just stayed on the ground as time ticked on. Okay. Very good. Next one. Okay. Here's their answer. Running touches first. They had it just over 72. Rounded third. And now he's going straight to home plate at the end. Something like that? Yeah, close. Not bad. Let's talk about this graph again. What happens at this point in the graph? Yeah, he goes to second, right? He's still going away from home, but not quite as quickly as he was when he was running away from first. At this point in the graph, hits second. He's getting closer to home, but not quite that quickly. And then here's where he touches third, and he's getting to home pretty quickly. Doesn't take him that long in seconds. Very good. All right. Number 5. We're measuring the distance of this bar to the bench. And we're going to go our dependent variable. We're going to go by half feet. We're still independent variables in 15 seconds. All right, one time through full speed, here's what happens. Think about how the graph may look. Again, from the bar to the bench. Measuring feet from the bar to the bench. Here's the best part. That's it. All right. So here's the half speed. Here's their answer. They started about 3. He came down pretty fast, a little slower on the second one, but somewhere around there. He's back down. There's where he's struggling. Time's still ticking on. He's barely moving the bar, but finally he gets it back up to normal. And there's our graph. Something close to that? Yeah? Not bad? Again, they were really specific here. You know, I thought it looked like he was doing it at almost the same rate, but they were really specific that he dropped down fast there and then took a little longer there. But that struggle period would be right there. Okay. All right, let's see the next one. Next one, Bullhide off the ground. So, they go by 4 feet scale for their dependent variable. Here's 1 time through full speed. What would this graph look like? Real exciting, right? Yeah. All right. Here's their answer. They started about 36. She hadn't moved much. How come they just didn't draw a straight line down to the end? Yeah, because those little humps there at the end, right? Those little humps that she didn't just go immediately straight down. Yeah. She had the bumps in the slide, so that would be those little periods there. Very good. So here we're going to graph the balloon length in inches, and let's make our scale by 1.5 feet. So it's going to be skip 1, 3, skip 1, 6, look like that. All right, there's your graph. Here's their answer. They had it starting at about 3. It's increasing in length. What's happening at these steps? Yeah, he's taking his breath, right? The balloon's not increasing in length. And then it just, here's where he lets it go and it just takes off back to its normal length. We at least have this part in our graph, probably, right? Yeah? It just pretty quickly decreases back to normal.